Hello, everybody, and welcome to Unit 6 of Regents Chemistry, where we will be talking about the periodic table of elements. So today our discussion will be how are the elements classified and organized in the periodic table. So just talking a little bit about the history, uh, Dmitry Mendeleev was the first person who kind of organized some elements in the form of a table. He was a Russian chemist, and what he observed was that when elements were arranged in order of their increasing atomic mass, he said that we do observe similar chemical and physical properties after like specific intervals. And based on that, he came up with the first ever periodic table in which he arranged the elements based on their increasing atomic mass. So the difference between Mendeleev's periodic table and the one that we follow today is that in the modern periodic table, elements are arranged based on their increasing atomic numbers rather than the atomic masses. So Henry Mazzello was the first person who kind of identified the atomic numbers of the elements, and he used X-rays to do that. And he was the first person who arranged the elements based on the increasing atomic numbers. And that is what gave us the modern periodic law. This law says that the properties of all of the elements out there are a periodic function of their atomic numbers, which means that depending on if you look at any specific element in the periodic table, depending on in which group and in which period, we'll talk about what both of these words mean in just a bit. So depending on where do we specifically find an element in the periodic table, it has some specific properties. So just by finding or locating any element in the periodic table, we can kind of identify some of the properties that that element might have. So here you guys see the periodic table that's given in your reference table packet. And let's quickly look at how the elements are arranged and organized and classified in that table. So the first thing that we'll be talking about are the periods in the periodic table. So here's just a small chunk from that table that you guys just saw, that big table. And periods right here are the horizontal rows that we have in our periodic table. So basically, overall, we have 1, 2, 3, 4, 5, 6, 7. 7 of those rows, which means we have 7 periods in the periodic table. So the first period would contain hydrogen and helium. Second would then contain lithium, beryllium, and so on. Okay, so what do these periods tell us? The period number specifically just indicates the energy level in which we'll have the valence electrons. For example, let's say we are looking at sodium here. Sodium has the symbol Na. It's in the third period. So that tells us that sodium will have its valence electrons in the third orbit or third energy level. And if you guys look at the electron configuration for sodium Na, it's 281. So definitely it only has one valence electron, which is located in the third orbit. So that's what the number of the period tells us. And next up, we've got the groups, or which are also sometimes referred to as the families in the periodic table. And this is once again at the bottom, you guys see a small chunk from that big periodic table. So groups are the vertical columns that we see. So if you look here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 columns or 18 groups in the periodic table. And elements in one group will have the same number of valence electrons. So for example, all the elements in, let's say, group 13 are going to have 3 valence electrons. All the elements in group 17 are going to have 7 valence electrons. Now, because they have the same number of valence electrons, they are going to have similar properties and they will react similarly. Okay, so and that is exactly what the periodic law said. Now that was our first concept about the periods and the groups. Now the next thing that you need to know is that overall in the periodic table, elements are arranged in three main categories, which are the metals, the nonmetals, and the metalloids. So let's start with the metals in our periodic table. Here we have the table in front of us, and metals are all of the elements on the left. So all of these right here are going to be the metals in the periodic table. And then if you guys see these two lines at the bottom, this table right here, this group of elements are supposed to be uh, a part of those metals, but because that would just make the periodic table way too long, so that's why they're just placed at the bottom. But these are also considered the metals. So some of the properties of the metals include they have a metallic luster, which means they have a shine to them. They are malleable, which means they can be folded, bent easily, and they can be shaped into like sheets and stuff. They are ductile, which means they can be shaped into wires. They are good conductors of heat and electricity. This is like one of the most basic properties of metals, that they are good conductors of heat and electricity. And normally, most of the solids out there are solids at room temperature or at STP, which is the standard temperature and pressure, except Hg, which is mercury. And mercury, because mercury is a liquid at room temperature. And one thing to remember about metals, alongside all of the other things, is that metals tend to lose electrons. So they make positive ions, which are called the cations. Next up, we have the nonmetals, and nonmetals are on the right side of our periodic table. So all of these elements right here are going to be our nonmetals, including this helium and hydrogen at the top. So some of the properties of nonmetals are that they have a non-metallic luster, which means they don't have that shine to them. They are brittle when they're in the solid phase, which means even though they are solid, they are kind of hard, but it's still very easy to break them. They are poor conductors of heat and electricity, and most of them are gases at room temperature. Some of them do exist as solids when they are in the molecular form. The only exception to this gas and solid phase is bromine, and bromine is a liquid at room temperature. So alongside some other things, one very important thing to remember about nonmetals is that nonmetals tend to gain electrons. So when they gain those electrons, the negative things, they form negative ions, which are called the anions. Okay, and finally we have the metalloids, which are these elements right here that are close to that zigzag that you guys see in your periodic table. The only exception to this is aluminum and polonium. So even though these two elements are very close to the zigzag, they are still considered metals rather than metalloids. So when it comes to talking about the properties of metalloids, they have some properties that metals have, and they have some properties that non-metals have. So they don't really have anything like fixed to themselves. They're kind of in the middle of both. Now, another important thing to remember that does come up in some of the questions is that the most reactive metal that we have on the periodic table is francium, which is right here. And the most reactive nonmetal that we have on the periodic table is fluorine, which is right here. So both of them start with an F, but remember francium Fr is a metal and fluorine F is a nonmetal. Now next up, let's talk about some of the classifications that we see of the elements in the periodic table. So some of the common groups that are used to classify the elements in the periodic table are these. And let's quickly look at where do we have all of these groups in the periodic table. So the first group that we have in our periodic table are the alkali metals, which are group 1 in the periodic table. And these all of the elements in this group form soluble compounds, which mean they make compounds that can be dissolved in water. Then we have the alkaline earth metals, which are in group 2 in our periodic table, and they form both soluble and insoluble compounds. Now, both of them are metals, very, very strong metals, so they make very strong cations or positive ions because they tend to lose electrons. Then we've got the transition metals, which are all of these metals right here. And then remember these two like these two rows of elements that are stemming out of the transition metals, they are still part of the transition metals. Sometimes we also like to call them inner transition metals. And then we've got the halogens in group 17. So these are very, very strong nonmetals. They tend to form negative ions or the anions, and they're very reactive. They tend to gain electrons. And finally, we have the noble gases in the very last group 18. And these have their complete octets. They are stable, 8 valence electrons, so they tend not to react to anything. So basically, what happens is that we have these two main groups in which we further divide the groups. So we've got this first group of representative elements, which have all the elements in group 1, 2, and then group 13 to 17. The reason we call them representative elements is because they do follow some of the rules or trends that we will be talking about in the next topic. Um, so that's why we call them representative, because they do follow all of those rules. But then we've also got these transition metals that we have in the middle right there, and these elements do not quite follow those trends or rules. So whenever we talk about those trends, we are most likely basically just talking about our representative elements only. And finally, the last thing to know about the organization of elements in the periodic table is that overall we've got two liquids in the periodic table, which are mercury and bromine. So mercury is a metal and bromine is a nonmetal. And we have 11 gases on the periodic table, which of course, first of all, include all these noble gases. And then other than the noble gases, they also have hydrogen, and then these four: nitrogen, oxygen, fluorine, and chlorine. Now, these five gases, hydrogen, nitrogen, oxygen, fluorine, chlorine, all of them are very reactive. However, the noble gases, which are in the last column, they typically do not react. And then everything else that we have in the periodic table is, for the most part, a solid. Alrighty, beautiful people. So that was it for the classification of elements in the periodic table. Happy learning, and I'll see you guys in the next one.